All
I was
right.
going to say just a few things too to get started. To get started too, Patrick. Get this working.
Cool. All right. Um, we'll give you a minute to get set there, but this session is going to be the librados review. It looks like we're going to focus primarily on the object or threading stuff and the parallel reads. Although I'm sure any librados questions or discussion will be welcome. So, Sage, go ahead and take it away whenever you're ready.
Sure, Patrick. Is this sharing my screen? I can't
Yep.
tell if Blue Jeans is. It is.
Yeah.
All right. Okay. Well, I was just going to say before I jump into the librados thing, just say a few things about development process and getting involved and all that good stuff. So, PDSGH. So the first thing is that if you want to get involved in Ceph development, the key is figuring out how to reach developers. So the best way to get involved is via the mailing list or IRC. So we have several different development lists now. So Ceph Devel is at vdra.canal.org. That's where all the general Ceph development email discussion goes, and that's sort of the first place to look. When we open sourced Calamari, we created a separate list for Calamari, since that tends to be a little bit different as far as what topics are discussed and so forth. So there's a Ceph Calamari list as well. So if you're interested in the management layer or web GUI, that's the place to go. And there's also a Ceph maintainers list that not too many people know about, but that's where the Debian and Fedora and Ubuntu package maintainers make sure that all the Ceph packages are sort of doing everything the right way and can get properly included in all the downstream distros. So you should get on one or all of those lists, depending on your interest. And of course, IRC is really the best place to find us all. Ceph.devel on irc.otc.net. Um, Submitting code, obviously, everything is on GitHub. We use GitHub pull requests to capture code review and also to merge most code. That's sort of the easiest way to get attention. Um, that and pinging individuals on IRC. The feature tracker obviously is the place to look for work and to, if you have a problem, log a bug and so forth. And again, the Ceph development list, if you have any questions or aren't sure what's going on, everybody there is very eager to help get new people involved. I wanted to talk about one thing that's a little bit new though. Um, I want to introduce the concept of a technical lead into the project. Up until this point, we've had sort of this amorphous team and process and as far as who is responsible for what and so forth. So the idea with the tech lead is sort of just identify somebody who has sort of a technical architectural leadership role for a particular part of Ceph, and their responsibilities generally would be to sort of shepherd the code review for that particular component for those pull requests, make sure that the requests and patches and so forth that are coming in are addressed and um, either revised and so forth, or um, tell who should be reviewing it or whatever, or merged. Um, Also, there's some the need to sort of guide the prioritization of the backlog. In the feature tracker, we've got all sorts of different um, things that we want to do in the project, and figuring out sort of what should be sequenced next um, to sort of maximize stability and so forth for the project. And also, sort of the last thing is to, as we do these summits, we want to make sure that we're talking about all the sort of major components of stuff, whether it's RBD or core Rados or the file system or whatever. And so figuring out what topics are going to make the most sense to discuss for the next sort of development cycle, and how we should generally be focusing our efforts. This is a sort of input that I'm hoping to, by identifying these people, have more involvement in those pieces and so forth. So, without further ado, this list probably isn't a surprise to much of anybody. These are sort of the people who are the key individuals responsible for different parts of the system. So for core Rados, the low-level distributed object layer, Sam Just is definitely the go-to person who's the deepest in the code, and generally has the most insight as far as what should be done when and how. For the Rados block device, Josh Durgan has written much of that code, and is sort of the expert on RBD and also a lot of the integrations as far as how it ties into OpenStack and so forth. Rados Gateway, the S3 Swift proxy gateway tool. Yehuda is the person. It's the person to talk to, and you'll you'll generally notice this when you ask these questions on the mailing list. These are the people who generally respond. On a Ceph file system, we have a couple of different people. So Greg is the person internally on the team who generally does all things file system. And Jung Yan at Intel is sort of our biggest contributor, who's been doing sending in the most patches and doing a lot of work with the multi-MDS stability, and probably has his head best wrapped around some of the nitty-gritty internals of how the multi-MDS clustering stuff works. So I think between these two, we have sort of the right combination of knowing where we should be going technically, and specifically how we should be addressing all the little issues. For the new Calamari project, Gregory Mino leads that team internally, and I think is the sort of the person who is going to be plotting the overall vision for the foreseeable future. So, and this Calamari I think is interesting because there's sort of two components. There's the backend part that's really has all the messaging bus and all the aggregating information from all the different Ceph nodes and providing the sort of RESTful API for managing the cluster. And then there's also a UI front end component that was previously worked on mostly by Jan, but now sort of looking for people to pick up those pieces. So it might be that we'll sort of break those apart later, but we'll see. Truthology, the testing framework for Ceph, is Zach's primary day job, and he's doing a lot of good work there, refactoring it to make it easier to install, to make it a simpler overall system, and to generalize things so that it can more easily be pointed at different cloud backends, so you can easily sort of stand up your own Ceph testing infrastructure, and also sort of pushing forward this vision that the test frameworks should be general enough to run and test other distributed systems other than Ceph. Is sort of the vision to make this the tool that we would have wanted 3 years ago, that would have avoided us having to write our own. Ceph Deploy is the easy Ceph deployment tool. Alfredo Deza is the one who has been doing most of this work. And on the Chef cookbooks that are used for deploying stuff with Chef, Gilham Letron has stepped up, I think like 6 months ago or whatever, to maintain those. So these are sort of the ones that come to mind. I think there are other sort of areas where people have some level of ownership. My goal is really just to put this on the wiki somewhere and identify these people. If you sort of see this, it'll probably change over time. If you see that there are other sort of specific components that have a clear person who is sort of leading that project technically, then we can continue to expand those lists and adjust names as time goes on. But I wanted to call these people out because they're doing great work. And if you have questions about any of these particular areas, these are the people to go to. Just a few other bits and pieces for people who are trying to get involved. A big piece of getting your code merged is getting it tested. So generally, one of the first things is once the code hits the mainline Ceph tree in a branch, we have these Git builders that go off and build them for all the different distros and packages and run all the unit tests. You can see the status at Git builder at that URL. And then Pulpito is a newish tool that Zach's been working on that is the sort of the web front end for all of our integration test infrastructure that we have. So Truthology is running all these tests in the back end by allocating machines and churning through a bunch of work. And Pulpito is where you can actually see those results. So that's a public facing website as well. And as we get more people involved in development, the key is to get everybody sort of plugged into all this infrastructure so that we're all using the same tools and the same sort of CI process and so forth, so you can get involved. So, and then the last thing I wanted to talk about was that the release cadence has sort of been a big question about how we're going to do this going forward. So in the past, we did a named release every 3 months. That basically meant 2 months of actual coding and then 1 month of hardening and QA before we did our sort of named cephalopod releases. And then as Inktank, sort of previously, every other one of those was sort of supported as part of the Inktank Ceph Enterprise release. More recently, our Firefly release, because we wanted to get erasure coding and cache steering in there, and those were sort of big chunky features that ended up being pretty challenging to get integrated completely. That timeline slipped by 2-3 months, so we sort of missed our window, our train by a lot. So one of the questions that we're sort of trying to figure out is what should we be doing in the future? And I think the questions are, I think there within the team here at least there seems to be a general consensus that we want to have a timeline type train release. So we do regular releases regardless of what features are in or out. And if things aren't ready, then they don't get merged, and then we stabilize what we have and so forth. So I think there's people generally like that, and that sort of frees us up from the demands of the product side of Red Hat or any other company and what they want to ship in a product. But as far as our upstream engineering effort, we just sort of focus on getting things in when they're ready and not sooner. So that's true, but there's a question about timing, whether we still want to do sort of a named release every 3 months, even though there may or may not be anybody supporting that, and backporting those patches is 3 months too frequently. On the other hand, it's nice to get sort of releases that have gone through a significant amount of QA that are sort of safe to run for brave new souls who are trying to sort of push the technology forward and want to get a preview of new features. So we're sort of trying to figure out what the balance is there. So over the course of the next couple of days, be thinking about this and share your thoughts with us either in the channel or in the sessions. We didn't actually schedule a specific slot to discuss this, but we can sort of slip it in when we have gaps, or we could add it in, and definitely if we can bring this up in the mailing list too. But I wanted to flag this as something that we should all be thinking about. So that's it for my little intro bit. Which brings us to, I guess, what are we supposed to be talking about right now, Patrick?
We're on the
librados review.
Yeah.
Got it. Okay. All right. So there were sort of two things that we discussed at the last summit for Roger. Two things that we discussed at the last summit for librados that have made some progress. Well, one of them's made progress. One is changing the internal threading model for the librados library so we can better handle high IOPS workloads. And we made significant progress there, although it's not quite landed yet in master. And the other thing was that we talked about was supporting sort of parallel reads to reduce latency. That's actually something that's a relatively simple implement, but we haven't done yet. So I guess I can start with that one. The basic idea is that if you have IOPS to spare on the back end and you have a latency sensitive application and you're doing replication, then you could just send the read request to all replicas, and whichever one comes back first, you use, and you ignore the other replies. And that obviously is going to cost you a bunch of IO on the back end. But for latency sensitive applications, that might be just fine because you want to avoid sort of the long tail, improbable case where you have a spike on that one primary that you have to be reading from and end up piled up behind that node. So this continues to be something that's going to be pretty simple to implement, but we haven't done yet. So if this is something that you're interested in for your particular application and want to, jump in and do some work, raise your hand on the mailing list or IRC or whatever, and there are several people who will be happy to help walk you through that. That'd be a great sort of new addition. The more meaty one is the object threading. So this is a piece of work that Ehud has been working on for the last couple of months. And the basic goal here is that we have a bunch of things that are sitting on top of librados, and at the same time, people have this desire to run Flash backends underneath their OSDs and get really good performance as a result. And previously, librados was the sort of the object thing that it wraps in the internal name of the module that's doing all the client initiation for the Rados IOs had a single global lock basically. And so if you're doing lots of IOs, everybody's piling up on this one lock, and you can't, there's a limit to the number of IOPS you can do. So this main effort was to basically break that lock down into a bunch of smaller locks and use reader-writer locks and some atomics and a bunch of other sort of the usual multi-threading lock trickery to make that happen. One of the first steps was to make the way that the objector module was sort of inheriting the lock of its client that it was using. It sort of existed under somebody else's locking scheme, to sort of graduate it so it had its own set of locks and was multi-thread safe, essentially. And then we created a read-write lock around the list of OSDs that we're talking to, essentially the map of what OSD sessions we have open. And so you take a read lock to get the session that you want, take its lock, and then you drop that read lock. And then the actual individual connections between the client and a particular OSD have a lock that is read write and that you end up serializing on. So the situation, if you have a single OSD and a single client, doesn't change much because you're still piling up on a per OSD lock. But in any normal cluster, you have hundreds of OSDs. So effectively, we've broken this one global lock down into 100 smaller locks, which gives you much better parallelism. And at some level, you always have to serialize on that individual OSD connection because they're going over the same TCP pipe and they're ordered when they go over that pipe. So there's some serialization that has to happen there. But we've sort of eliminated the synchrony between all the messages that are going to different OSDs. So current status of that work is that it's largely complete, except that after the last rebase, it started failing some of the integration tests. And so we just need to figure out what happened, what broke sort of at the last minute, get that cleaned up, and so we can get it merged again. And that's been delayed from a bunch of other random stuff that's happening. Last week, a lot of the team here at Ink Tank was in Raleigh at Red Hat doing our orientation, so not much happened last 7 days. We're sort of eager to get back to this. And now Yehuda's on vacation, of course, so it'll be it might be a few more days. But that is in progress. So that's the current status there. Somebody in the Etherpad added a link for the new blueprints for GH. So this is work that's going to be happening over the summer. And it's around tracing. So the idea is trace, capture, and replay at the librados level, and probably doing something similar at like librd and some of the other client sides. And the general, I don't know if I guess we don't have a separate session for this, so I'll talk about it now. But the basic idea is that we want to be able to have a way on a live cluster to go in and capture a trace of what the current IO looks like, either get an actual explicit trace of this is actually every IO that's happening, or feed that information into something that is just characterizing what the IO looks like, how big the IOs are and what patterns that they exhibit and so forth, so that we can understand what workloads customers are seeing or users are seeing in actual clusters. And then later, when we go back and we're doing development, we can replay those same traces or workloads that are substantially similar, so that we can see how the cluster is going to perform under sort of realistic workloads, which is always a challenge. Just running random benchmark applications does not have very much bearing on what people see in production or reality. So that's what that blueprint is about. And we have a couple people here, or at least one person here for the summer. Adam Kroom is going to be doing some of this work, specifically in the context of librd. And I believe somebody was, Sam actually wrote a blueprint. He wants to do the same thing specifically for the objector. So that's sort of the picture for librados. I guess, are there any questions in the channel, or any general questions about what we're going to be covering over the next couple of days before we sort of dive into all these sessions? Or in the room, I guess people can just unmute and start talking, huh?
Amazing.
This is way better than Hangouts. I never thought I would see the day. Dun, dun, dun.
Doesn't look like anybody has any questions. You've covered everything.
Vacuum asks, could those parallel reads have a consistency check feature? If all replicas are reads anyways, they could calculate a lightweight checksum. And if this more the same. So yes, we could do that. You could actually do that just above librados also, where if your application could just read from all replicas and, well, no, actually you couldn't. That's a good idea. So one of the things that Sam's going to talk about, I can't remember if it's today or tomorrow. I think today, is improving the scrubbing and repair mechanism. And one component of that is sort of exposing through some of the internal or low-level APIs is the ability to say, how many replicas do I have? And can you give me the data for each of those individual replicas, so that when scrubbing does detect that there's some inconsistency, you can actually examine what those different objects are and then make some decision like, oh, this is the one that I want, and repair all the other replicas based on this one, which I decide to be the correct one. So I think some of that infrastructure is going to be similar to what you're asking for. I hadn't sort of originally thought about just sort of magically having this mode where it reads all replicas and only returns it if they all match, but that would be a good thing too. One of the general problems is because we're sort of sitting on top of existing local file systems, we're sort of trusting that they're going to return us the right data, and then scrubbing comes back periodically to detect if that's not the case. But if you're doing an individual read, you don't necessarily know that it's perfectly correct. But that would be an expensive way that you could sort of put the cluster in a paranoid mode or something like that. That would make sure that you don't get back data that is questionable. That'd be pretty cool. That's a good idea. Yeah. Is Sam on, by the way? I don't see him on here.
Yes.
Oh, you are? Okay.
Yeah.
Cool.
Looks like he's dialed in by phone or just audio only. Yeah.
I just turned the camera off.
Ah.
Anonymous. Okay. Cool. Okay. Okay. Well, the next one is OSD review.
Yeah, this is, so actually let me, I'm going to break the recording so that they're easier
Okay.
on YouTube.
All right.
But yeah.